Hello and welcome. It's pretty late. I'm going to try to be quiet. This is going to be another recording. I'm just kind of sharing, I guess, my updated research on events of the KT boundary. So this episode, as well as Chicxulub, was not alone this episode. And I was just, before I hit record, I was like, are any of these, maybe some of these, if not, well, this one maybe. I mean, for sure the topic is related for these, but they may not be. Exactly like this. I'm just gonna literally be reading my notebook of things that I found that were happening at the KT boundary, which is basically, like, if we go to KT boundary, so Alvarez, his son Alvarez, so physicist, geologist, father son, which is cool. Because interesting about this, they proposed the impact, but basically they rolled out. Let's bring it up. They ruled out a supernova. Reasons are given to indicate that this iridium is of extraterrestrial origin, but that did not come from a nearby supernova. I didn't look to try to find this paper. Maybe I can now. Alvarez. Cool. Super. Okay. Really? That's the only time? Okay, we can't text search the actual document. Okay. Supernova. Let's see if there's like a supernova discussion. Platinum metals in deep sea sediments. This study began with the realization that the platinum group elements, platinum, iridium, osmium, rhodium, are much less abundant in the Earth's crust and upper mantle than they are in chondritic meteorites in average solar system material. Depletion of the platinum group elements in the Earth's crust and upper mantle is probably the result of concentration of these elements in the Earth's core. And also maybe the currents flowing and causing differentiation that led to a supernova of regions that became basically these elements in a huge particle type structure that novaed and just sent emplaced nodes of like gold, copper, etc. I know how ridiculous it sounds, but it fits the data. So it's really interesting that the initial proposal of an asteroid or meteorite impact in that time frame at the KT boundary is actually proposed simultaneous with a supernova. I was having this thought, like, even if they, like, fail to have ruled out a supernova, it doesn't mean, like, because essentially what I've been saying is that the currents flowed, for more information, see other videos, currents flowed and compacted in the Pacific in a way where they basically flowed out from one point, out around, and then compacted in the Pacific and caused like a sphere that had current flow and like vortices going on that then became so large and imbalanced that it's literally supernovaed on its scale, where it was like a microplanet, so it wasn't like a star supernova, but it was a big particle. It wasn't just like a pebble. It was a big system, and it novaed and distributed across the entire surface, the KT boundary layer, which, if this particle that novaed, as ridiculous as this might sound, if it literally is the sphere of Hawaii that decayed, see my Hawaii videos. Really though, like, it's important to that concept of what I'm talking about, why I'm talking about this, why I'm looking at this, why I think it actually makes sense based on the evidence. It's not like I'm just like concluding things. I'm looking at what the evidence is, and then adjusting the nuances of my understanding to account for it, but still, like, doing it because it's genuinely appropriate. That's my thought. Like, the fact that I've made it this far is absurd, obscene. To have to be able to account for so much data is just like of a wide spectrum. So, like, to even have this thought of a supernova, but, like, back to what I was saying. Hawaii was a sphere. It formed as a sphere that literally rolled out atop the oceanic crust from over here. It basically made its way, as ridiculous as this sounds, it made its way from underneath Australia, which was over here at the time, and went up this way. And, like, in the process, it novaed. Maybe it wasn't exactly Hawaii, but Hawaii maybe was like a decay product that got, like, shot out. And while the system decayed, it, like, released a sphere, like the nucleus of the particle was ejected, and it went over this way, and basically ended up making it all the way to here by the time the Earth started to rapidly expand, at which point the currents that were moving it basically caused it to, or relented, essentially, I believe, in a way where it started to just roll back down. But then it ran into resistance over here, which I believe is, like, just from the elevation change in this region and just the current flows that may be still somewhat present and somewhat influencing, like, forcing, like, a way, so it basically bounces off of the current, which is all based on this map. See other videos. I don't want to get stuck talking about details. I know it's ridiculous if you don't know what I'm talking about, but it is what it is. This is episode whatever. Like, it's not episode 2. I could see if it was like episode 4. Like, but at this point, I'm like, what do I do? I've been talking for days, dude. Literally days. So let's check out some stuff that I found. Argon 4039 dating. Siberian traps. Evaluation of ages of two major extinction events relative to episodes of flood basalts volcanics in Siberian traps and Deccan traps. I don't know I don't know what I was writing this for, but then I put 238 plus or minus 1.4, 238.4 plus or minus 1.4 million years. First lava flow duration 5 to 10. Okay, so I think it was mainly because the Siberian traps duration was 5 to 10 million years, according to radiometric dating. And that it post-dates the Permian-Triassic boundary, whereas the Deccan traps are coincident or simultaneous with or overlapping the KT boundary. Okay, which to me means like maybe the Permian-Triassic boundary would be tied more closely to the Australia, like super volcanoes around that time frame of the Siberian traps. If we were to tie it to some event like we did Chicxulub, but it's really just like a like spike in the emissions of energy in the process. Okay. A late Cretaceous. This one was so fascinating. Did I talk about this? I don't think I talked about this. Let me just see. I got 4 pages of notes to talk about. Fuck. Cretaceous mixed turbidite conturite system along. I know, guys. I know. Stick with me. I probably didn't need to type all that, but it's kind of fun. Okay. Of course, while watching football today, I was reading papers. I'm pretty sure that this was today still, and I didn't talk about this yet. So basically, let's go to Google Maps. Town, I believe it's in this region here, is where this paper's talking about. Just below Uruguay. Okay. Turbidity currents along slope bottom currents. Two of main deep water processes that shape continental margins. What I found interesting about this is there are contrasting theories that started to grab my attention. Bottom currents flow along slope sub-parallel to bathymetric contours on a semi-permanent basis, while gravity flows are rapid, sediment-laden flows moving downslope, so two crossing currents are present. Immediately piqued my interest. Pretty sure this is still from the abstract. Interaction builds large, mixed, or hybrid turbidite, conturite depositional systems, several mixed systems in the Cenozoic record, fewer in the Mesozoic. several in the post 66 million, fewer pre 66 million. A wide variety of mixed sediments lack proper identification. Other examples along East African shores suggest bottom current flows down current. Cenozoic Antarctic Peninsula, South China Sea exhibit bottom current flows up current. I just kind of wrote it. Pardon me, I know it probably made no sense, but this paper, check it out if you feel inclined. I didn't read it all. I read a couple pages before I was like, all right, I'm gonna just move on. But like the information in it certainly was pointing to some things I've been talking about. I was thinking, like, I'll just go on. Southeast Atlantic, approximately 15 kilometers of sediment. So this is a lot of material. Argentine margin is what we're focused on. I guess just the whole region, which is then divided into 5 segments in the paper. A Pasic volcanic margin characterized by an extensive mixed depositional system. A passive volcanic margin formed during breakup of Gondwana and the diachronous south to north opening of the South Atlantic Ocean. So the opening of the ocean, breakup of Gondwana. Mind you, I've been saying this supernova sent energy this way, this way, this way, this way, between here, which was up here, between here, but then as it did so, it then ended up going this way, which then probably like went up this way as well to just like finish the breaking apart of the 2 large chunks that needed to be broken apart. Otherwise it'd be just like they wouldn't fit because the earth was smaller radius and they needed to break apart to like flatten. Mechanism led to continental crust rupture, which is controversial. Important aspects. First, inherited. Wait, let me just skip a bit. This is just stuff that I was a little nuanced. It's okay. I'll go to my stars. Seaward dipping. Maybe I should not do that. Final opening of between Argentina and South Africa, 127 to 135 million years radiometric dating. Continental breakup, so around that time, which is relevant also in the Baja BC interpretation of things at the time frame and has come up in other places. So I found that relevant. Seaward dipping reflectors are a term that I found of interest associated with transition from continental rifting to full lithospheric separation and seafloor spreading. So at 66 million years, there is this transition. I'm pretty sure that's when it happens, where these seaward dipping reflectors transition from continental rifting to full lithospheric separation, which is basically when the undercurrents no longer flowed underneath any of the continents, because initially there was only the continents to flow under, but then cracks formed between them. And so at some point there was only really the cracks to flow into. Then the current just filled the space where the cracks were, according to the oceanic crustal age. Basically, like all this red through yellow, some of the green. So like all this formed after the rapid expansion of the Earth began, which was probably what they're referring to of this transition from continental rifting to full lithospheric separation. Suggests also a multi-stage rift propagation, in this paper says. Suggests also a multi-stage rift propagation of how this is separating in 400 kilometer segments. So it's almost like node, like certain like bond points that are stronger than the rest of the distance. That like that wavelength, maybe, if you will, broke those nodes. I don't know, just something like of that nature, where there's specifically like repetitive distances of just like bursts of propagation of the current, because essentially it reaches a resistance and it can't really do anything, so it has to build up like the pressure again, and then the sufficient pressure builds up and then it breaks through to the next point where it's like that's as far as you could get, another 400 kilometers, and then it builds up, breaks through, and maybe it's not exactly the same, and there's nuance that adds like detail. Maybe it like gets shorter distances going this way because it's coming from a current that was ultimately coming this way. Something of that nature maybe is present. I don't know. I'm just spitballing. Okay. Let's see. 4 segments, they called them tectonic segments, 1 to 4, separated by transfer fault zones, which I'm not sure. That was basically these things, these segments. Here. So I guess it might actually not really be here. Sorry, it's out here. That's right. It kind of goes in here some of the times, and they describe it going in, so maybe that's what's going on. But I think it's more focused out here. Okay. Begin on 120 kilometers onshore, so like this way, but extend 500 kilometers offshore, and then they let's see if I can find it. Experienced. Okay, so this is really this time frame here. The Argentine margin, the change in deposition style of the margin from a gravity dominated to bottom current dominated, like building of the margin, I guess. Pre-drift stage 124 to 89.8 million years. Onset stage 89.1 to 81 million. Growth stage 81 to 66 million. And then burial stage, they have greater than 66 million? So maybe marks the cessation of the mixed system due to bottom current intensification and transition to a pure contourite system which persists until the present day. Whoa. Maybe it didn't even have to like specifically go around, and instead, like, there's a current going this way. I don't want to get too caught in adding detail. It's late, and they might hear me. My aunt and uncle are sleeping. But like, the current generally makes it down this way and runs into resistance here, which I've talked about in basically happening here. Like as it opens, as South America moves away, this gap opens, but then up here moves up this way, so that this ends up meeting these two currents. There's two currents meeting here that produce this shape. And so it ends up moving up South America. But like hitting a boundary. Or actually, sorry, that's right. It's not actually hitting South America. This is like going to the entry point, and then it's going with like a flame along its boundary. I know it's a little confusing because I'm not making sense right now. But essentially that arrow is like feeding into these notches and shaping this region. So like there's probably an undercurrent caused by that generally propagating. That's what I'm getting at, is there's probably an undercurrent that was caused to propagate backwards when generally it was going this way most of the time. But then once this happened, it will like backflowed maybe, and to this day is now like the shape is like reshaped so that the current goes that way. Like there's a direction of flow. I don't know. Okay, let's move on from this one in general. Record the progressive deepening of, this is the same one though, deepening of the margin and the development of deep water settings due to separation of Africa and South America at 137 to 125. Formation of an equatorial gateway. I found that an interesting term. From 100 to 80 million, which reminiscent of Baja BC. It's really like building into the crescendo at 66 million. Establishment of a new intermediate and deep water circulation regime. Supernova. I found a couple granites. Okay, maybe. That's good enough. Pretty much here. 66 million granites, 78 million granite in Japan. That. So that's the general gist of this one. Let me see. Hafnium, I think. 2 pulses of granitoid, 66 million and 78 million, and a mafic group comprising HBl. I'm not sure what I wrote here. Gabbros. HBI. I don't know. Hafnium model granitoid ages 2479, 1392. So there's a million years. So there's significantly older ones. And then another set of like granitoids, which 1435, 748 million. So basically I wrote that down to like indicate, okay, there's older crust involved. And they said older lower crust that's involved in this, basically. Which I've been talking about this in general is just basically being a current. Again, everything's a current flowing this way between the boundary. Here's Japan, and here it's flowing this way, but like continuing, and creating this arc pretty much by the pressures of the current. And so like as it goes, it propagated imbalances in the current that led to openings pretty much from the, I guess, collisions, almost like a Pac-Man thing. Okay, Russian Far East, East Sikhati Allen area. Only late Cretaceous, intermediary, and Silicic volcanics enriched in something can be interpreted as subduction zones. So pretty much like there's some kind of subduction in far east Russia in the late Cretaceous, 66 million years. I saw something that referenced the Louisville Seamount chain, 66 million, and then other things said as old as 78.8 million. I just wrote that down pretty much. Cameroon line. Let's see where that is. Why did I write that down? Oh yeah, that's right. It's like specifically this. Okay. Magmatism, 65 million years. Although that one, maybe I was a little more just like, yeah, that one says it. I looked around and like, definitely there's more than 66 million going on, but like, this may actually even be tied to like major steps, like the different islands. Like as they were emitted, maybe they were at different major times when things were going on. I don't know. Okay, but that one basically formed in that time frame, generally speaking. Let's see. So basically, like, certainly there's something to the date. There's evidence that a mantle plume has existed in the region for about 140 million years, first remaining in roughly the same position while the African plate rotated above it, and then remaining stationary under the Oku area since around 66 million years ago. So since the Earth started to rapidly expand and currents relented. Oh, this one was fuck. Oh my god, dudes. Whoa. That title, though. It's like Leonardo DiCaprio. Sorry. I'm sorry. There it is. Is it? Scheiße. Please. I would like to see that. Maybe that's it right there. Oh, Squarespace. Oh, thank you. Thank you. We found it. Okay. Global sea level and the pattern of marine inundation on the Australian continent are inconsistent. We quantify this inconsistency and show that it is partly due to a long wavelength anomalous downward tilting of the continent to the northeast by 300 meters since the Eocene, which is a little anomalous time frame wise, admittedly. Oh, not that anomalous. I thought it was actually more starting around this. Probably from when the bonds broke. That really makes sense, actually. Because like things start to chill off around 50 million, 55 million in like Laurentia and other, or Laurentia, Yeah, Laurentia, but Laramide, I think. And other places like Baja, BC, I think have dates of that time frame where in essence, it made me feel that things were like cooling off in that time frame. So that would kind of make sense because what I'm thinking is basically I said this in my Dwarka video that Australia rode a wave from over here because Papua New Guinea was sitting here attached right here and it rode a wave away. And what did it do while it rode the wave? Did it stay flat? No, it rode the wave like a surfboard. As I was saying, Surfboard Australia, downward tilting of the continent to the northeast by 300 meters, since it was pushed along like a surfboard riding a wave. Downward tilting occurred as Australia approached the subduction systems in Southeast Asia and is recorded. Oh, maybe that's related to like it initially it didn't really need to like tilt, but as the ground below it began to approach a like elevation change, then it started to cause uplift. So it wasn't until it approached the Southeast Asian continent or region, I guess. Recorded by the progressive inundation of the northern margin of Australia. Okay. Okay, two more things. I wrote down fact. This is from this is the title. Somehow I found this. Maybe if I type that. Yes. Oh my god. I'm not actually sure that this is it. I'm pretty sure. Actually, it's one person. I thought it was a thesis, is why I didn't think this was it. Maybe I'm mistaking. Oh, there it is. There's the thesis. This is one beforehand. Notice this. I was like, wait a minute. Apparently I can't do that. Oh, wrong button. We'll get there. Cretaceous Tertiary boundary was marked by major impact events, which are reflected in the occurrence of the Chicxulub Shiva Baltish, which I've mentioned before, as well as the Nader crater, which has been since discovered since this paper. And they mention Silver Pit crater. So another one, I looked into this one, and people are like, no, it's not the case. No, it's not. It's not no, it's like proposed, but like it does generally span the time frame, and like this is a technical paper, so like there's some merit to the concept that it occurred, although maybe they're knowingly spanning the like boundary, just saying like it occurred in the range and just listing it. I don't know, but I thought that was interesting. Okay. Also, before I move on, Chicxulub occurred here on the coast. Nader Crater occurred here on the coast. Shiva Crater occurred here on the coast. Guess where? Guess where Silver Pit Crater was? Actually, it's not that coast, sorry. It's not that coast. It would be more coast if it was like literally over here. This over here is a little anomalous. It almost looks more like it's central to the North Sea. I wonder if it is. No, okay. If it's related to the forming of the North Sea, how old is the North Sea? Mainly the result of low Jurassic, lower Cretaceous rifting. Which was 201. So it could have been like cooling maybe and like vented through a crater. I don't know. That would probably vent through more of a volcano, but maybe a below ground volcano is just seen as a crater, like some eruption. Like here's the magma flowing under a crust layer and it erupts up through it, but then it only gets to like here and then it like branches out here, but it like keeps hitting here but branching out at that intermediary layer. Then it could maybe produce like a crater appearance above. Okay. So that's about all that I have for now. Thanks for hanging out. See you next time.